This is the matrix operation practice, a mixed practice for Monday. So I'm just going to go through each question. If you don't need this question, just keep fast forwarding until you find the one that you need. So first on number 1, what we would do is kind of like the distributive property, the 2 on the outside here is going to go to everything inside. The 3 is going to go to everything inside here. So it's just multiplication. So if we do 2 times 2, we get 4. 2 times 3, so on and so forth. Keep that addition between the matrices. So once you have those, now for our addition property, if we're working with 2 matrices, we have to make sure that they're both the same size before we can add them. Since they are both a 2 by 2, we're fine to go ahead and start adding. So when we add, we look at the first set and we add. So 4 plus -9 is -5. And then we jump to the next one, 8. Add that to 0. 8 plus 0 is 8. And then we'll go down to our 6, and we're adding that to 6, which is 12. And last is our -2 added to our 15, which is 13. And that would be your final answer. So here we have matrix multiplication. For matrix multiplication, you have to make sure that you can first multiply them. So here, this is a 2 by 2 matrix. This is a 2 by 3 matrix. So if we look at the inside numbers, okay, those are the exact same. That means, yes, we can multiply these matrices together. So our resulting matrix is going to be a 2 by 3 matrix. And that comes from these outside numbers. The 2 by 3 tells us the resulting size of the matrix. When we multiply matrices, we always multiply row by column every single time. So when we start, we're going to start with row 1, column 1. So we multiply those. We do 2 times 3 plus 4 times 6. And then we're going to move to the next column. So now we move to the second column here. So we'll have 2 times -2 plus 4 times 0. Then to our third column. So we'll have 2 times 7 plus 4 times -5. Now, once we're done with that row, we've done it to every single column. We're going to go ahead and go to the second row. First column. So in that row, we'll have 3 times 3 plus -1 times 6. Then we go to column 2. 3 times -2 plus -1 times 0. And then we go to the last column. Once you have those all written out, you are welcome to use your calculator to get the final answers. I'm going to go through them by hand just to show you, but you can put each of these into your calculators to get the answer. So here we would have 6 plus 24, which is 30. Here we would have -4 plus 0, which is -4. 14 minus 20, -6. 9 and a -6, which is 3. -6 and 0, which is -6. 21 and a +5 is 26. So if you look at our resulting matrix, it is in fact a 2 by 3 matrix. We have 2 rows and 3 columns. So for number 3, we're going to go ahead and multiply first. The order of operations applies even when we're talking about matrices. So we're going to go ahead and multiply these. Remember, when we multiply, it's row by column. And we have to make sure that they're the correct size. Here we have a 2 by 2 and a 2 by 2. So when we do this, we look for the inside. If the inside is the same, we're good to go ahead and multiply. Our result should be a 2 by 2 matrix. That's where those come from. This 2 and that 2 tell us what our result will be. So we're going to go ahead and multiply. When we multiply, we do row by column. So we're going to do row, column. There's our first entry. Now that I did column 1, I'm going to go to column 2. Now we're done with row 1. We've already done row 1. We're going to jump to row 2. Row 2, column 1. You notice I'm always doing first entry to first entry. So positive 3 to negative 3, and then second entry to second entry, negative 1 to 2. That's consistent throughout all of multiplying when it comes to matrices. So now we're on our last column. Keep in mind, look in the middle of every single one of my problems. There's always addition. There's always addition right there. Okay, that has to happen every single time. So again, you can do these in your calculator. You can do them by hand. Here I get negative 6 and 8. That would give me a positive 2. 0 and 20 would give me a positive 20. Negative 9 and negative 2 gives me a negative 11. 0 and negative 5 gives me negative 5. And that would be our final answer. Okay, this is very similar to number 3 at the very, oh, I'm sorry, we did not finish that problem. We did not finish number 3. Let me go back. We still need to add 2 times this matrix here. So this is just kind of like number 1. You have a scalar. So this matrix here will stay the same. So every single number in the second matrix will get multiplied by 2. And from there we just add. So here if I start at 2, I'm adding that to the 6 because they're the same located entry. And then I'll do 20 and 0, which is 20. Negative 11 and 4. It would be negative 7. Last, negative 5 and 10. There's our final answer for number 3. All right, number 4. We're doing row by column. When we multiply, we have a 2 by 2 and a 2 by 2. If we look at the insides, they're both 2. That means that we're good to go ahead and multiply. Our result is going to be those 2 outside numbers, a 2 by 2. So at the end, we should have a 2 by 2 matrix if we did our math right. All right, let's multiply row by column. Row by column. So we have 2 times 3 plus 4 times 2. Second column. Now we're done with that first row. We're going to go to the second row and multiply it to the first column to start. And then finally, to our last column here. Again, you can put these in your calculator or you can do it by hand. I'm going to go ahead and do it by hand here. That would be -6 and +8, which would be 2, 0, and 20, which would give us 20, -21, and -2 is -23, 0, and -5 would get us -5. And that is our final answer. Okay, so here we have multiplication again, so let's go ahead. This will be row by column multiplication. So here we have a 2 by 3. Here we have a 2 by 3. So if you look at our inside numbers, we have 2 and 3, and that is an issue. Okay, those numbers have to be the same. Okay, those two numbers in the middle have to be the same. If they're not, we cannot multiply this matrix, so this would be undefined. All right, next we have just some simple addition. So 2 is going to be added to 1. That would be 3. -5, add that to 2. That's -7. And then -3, you're going to add that to -3, which is -6. And that would be your final answer for that one. This next one looks a little bit different, but order of operations apply. So if we think about order of operations, we always do parentheses first. So we're going to go ahead and do the inside first, and then we'll apply this -5 at the very end. So it's kind of like what we did here in number 6. Add the first entry, add the second entry, add the third entry. Then each of those is going to get multiplied by -5. So 2 times -5 is -10. -5 times -2 is +10. -5 times 7 is -35. And that would be your final answer. All right, so next we have subtraction between 3 matrices, which is fine. We just have to do from left to right. And you want to make sure that they're all the same size. If they're not all the same size, it's automatically undefined. Since all of these are a 2 by 2, we can go ahead and multiply all of these. Or I'm sorry, subtract all of these. So we're going to go ahead and do these 2 first. So if we go ahead and do those first, we get 5 minus a -6. Okay, now we have double negatives there, which means we're going to have addition. So it'll actually be 5 plus 6. Then we're going to go ahead and go to our 3 and our 0. So we'll be here and here. 3 minus 0 is 3. And then 5 minus 1 is 4. And then we're at positive 1 minus a -4. That's kind of the same case with the 5 and the -6. 1 minus a -4 is like 1 plus 4, which is 5. Okay, we're going to drop this guy down, and now we're going to go ahead and subtract those 2 in the same exact process we did before. So the first one is going to be 11 minus 5, which is 6. 3 minus 4 is -1. 4 minus a -2 is positive 6 because we have a double negative there. And then 5 minus -6, double negative again, that would get us 11. So if it helps you, I'm going to go ahead and put colors in on these. The 11 and the 5 got us the 6. The 3 and the 4 got us the -1. hopefully that helps you kind of see. You just take the number that's in the same location and we subtracted them. On number 9, we have to go ahead and take care of this 5 first. So this first matrix is just going to stay as is. The second matrix, we're going to multiply everything in it by 5. And now we can add. So 1 and 20. So those are the colors that hopefully that helps you kind of see what you're going to add together. So we're going to do the yellows. 1 plus negative 20 is negative 19. 1 plus 30. 6 plus 5. Negative 4 plus 5. 0 plus negative 20. And 0 plus negative 5. And that would be your final answer for number 9. Okay, number 10 is where we get to the inverse. Find the inverse if possible. If not possible, write singular, meaning that there's no inverse for that matrix. This happens when the determinant equals 0. So the determinant is when we put 1 over AD minus BC. Okay, and for this process, I'll go ahead and put the equation here. We have D and A here. Those are switched from the normal, negative B and negative C here. That's going to be our equation for finding the inverse. If this part right here gets us 0, okay, if that equals 0, then it is singular, and we're done with the problem. So we're going to go ahead and check this one out. Okay, we'll call this matrix A. We're going to go ahead and find our inverse. So we'll have 1 over the determinant. So that's A times D. 11 times negative 1 is negative 11 minus B times C. B times C is negative 10. So what's going to happen here in the middle is those become addition. And then we're going to go ahead and put our matrix down here. So what happens when we flip our matrix is the 11 and the negative 1 switch locations. So I went ahead and I switched those locations. Then my negative 5 and my 2 stay where they're at, except they flip signs. So we change the signs on our B and our C. From here, it's just simplifying. So if we look at our denominator, negative 11 plus 10 is negative 1. And our matrix stays the same. So right here, this is going to become just negative 1. And then we distribute our negative 1 into every entry of our matrix. Basically, what happens here is our signs flip, and that's the inverse of our matrix. On to number 11. We're going to go ahead and do the exact same process. I'm just going to call this matrix B. So the inverse of our matrix, we're going to go ahead and do our determinant again. So negative 1 times 7 is negative 7 minus 7 times negative 1, which is negative 7. Oops, change that spot. So double negative becomes positive. We're going to go ahead and flip our numbers here. So these guys switch to locations. And then these guys, we just flip their sign. So what's going to happen right here is this is going to become 1 over 0. When that happens, it is singular. There's no inverse. All right, number 12, same deal. We're just going to call this one A. We're going to go ahead and do our determinant. So we multiply our -2 and our 8. And we multiply our 2 and our -9. We're going to get addition right here. All right, so these two guys, we're going to go ahead and flip our -2 and our 8. And then these two, the green guys here, we're going to go ahead and just flip the signs on those. Those just get the flip of the sign. We don't change their location. Now let's go ahead and simplify. -16 plus 18 is 2. And then all that's left to do is to multiply everything inside by 1/2. If it's going to be a fraction, just write it as a fraction. That would be our inverse for that one. Okay, we kind of talked about this on number 11, but a matrix is singular, okay, when the determinant equals 0. For example, if we're finding our inverse, okay, and we get 0, okay, this is just an example, but if we get 0 right here, okay, if that is 0, this is the telltale sign that it's singular. All right, solve the system of equations using matrix inverse. So first, we're going to go ahead and write our matrix. And you're going to need a graphing calculator for this one. So if you need to go ahead and get that out, go ahead and do that. The first thing we're going to do is go ahead and write matrix A. Matrix A is always going to be just the coefficients, or the numbers that are inside here on the left-hand side of the equal sign. And then we're going to go ahead and write matrix X. Matrix X is called our variable matrix. If you look at our original problem, we only have X and Y. So we're going to go ahead and put X and Y in here for these guys. If you had a 3 by 3 matrix, or sorry, 3 by 4 matrix, it would be X, Y, and Z. We're going to go ahead and put in B. B is what's on the right-hand side of the equal sign. So that's going to be these guys over here. All right, so what we do to find our to find our answer, to find X and Y, is we use the idea of the inverse. So we need to find the inverse of A. And what we do with that inverse is we multiply A by that inverse, and we also multiply B by that inverse. And I'm going to show you all of this on your calculator. So this is all done on the calculator. Okay, so I'm going to go ahead and pull up my calculator. Okay, and we're going to go ahead and practice putting in our matrices here. So we press second matrix. Okay, we want to go ahead and put in matrix A. So you're going to go over to edit, choose A. Now, A, if we look, is a 2 by 2. So when we go back here, we're going to have a 2 by 2. Change that. Then we go ahead and put in our numbers. 2, 9, 4, and 1. So matrix A is entered. Then you're going to press second mode, and then second matrix again, over to edit, put in matrix B. Matrix B is a 2 by 1, and our numbers there are -1 and 15. So again, I'm getting those numbers from right here. This guy was matrix A, this guy was matrix B. Those are what I put into my calculator. Okay, so like I said, we're going to go ahead and do A1 times A. So second mode will take us out. We're going to go into our matrix again, second matrix. You're just going to choose A. Then right over here, below the math button, that matrix button, if we don't press second before that, we just press the button, it'll give us the notation for inverse. So we can go ahead and press that. Then we'll hit multiply and then enter matrix A. So that's A1 times A, or A to the -1 times A. Press enter and it'll give you your matrix. Now, this should happen every single time when you do A1 times A, okay? Or if you do B1 times B on a different problem. You should always get something called the identity matrix, where ones are in the main diagonal, zeros everywhere else. So if we go back to our notes, this guy right here gave us the identity matrix. I'm going to move this down. Okay, now right beside it, we're going to go ahead and put our matrix X. We're going to need that. Our next step and our last step is to do A1 times B. So we're going to go back to our calculator and do A1 times B. So second matrix, choose A, and put that negative first, times second matrix, enter matrix B. Press enter. Once you get there, we're going to go back to our notes. And we got 4, -1. So if we look at this first row, okay, this is basically saying x equals 4. If we look at our second row, we have y equals -1. So for our solution to this system of equations, we get 4, -1. All right, solve the system of equations. So we're going to go ahead and write our matrix. And we start by writing matrix A. So we're going to go ahead and write matrix A first, which is just the coefficients. So these guys over here is going to be A. Oops. And then we write matrix X, which is just our coefficient matrix. Since we have 3 coefficients in our original system, X, Y, and Z, that's what gets entered to matrix X. And then last is matrix B, which is these numbers over here on the right-hand side of the equal sign. All right, to solve our system, we're going to do everything on the calculator. Okay, we're going to do A inverse times A. So I'm going to show you how to do that in the calculator, A inverse times A. And we're going to do A inverse times B. So A inverse times A and A inverse times B, and that will get us to solve our system. So go ahead and pull up your calculator. We're going input our matrix. So go into second matrix. Mine already has A in there, but I'm going to go ahead and just edit that. And we're now working with a 3 by 3. So we're going to put our numbers in. And then we'll input matrix B. I'm going to go ahead and edit that. Oops. Matrix B. We want a 3 by 1. And our matrix B is -1, 1, and -2. So again, those two matrices came from right here, matrix A, matrix B. So to do our process here, we're going to go ahead and do A times A1. So the first step is A times A1 right here. That's what we're going to do first. So second matrix, choose matrix A, choose the negative first power. That tells us we're using inverse of A, times matrix A, just enter matrix A again, but no -1, so you just want regular matrix A. Press enter. Again, you should always get 1s on the main diagonal, 0s everywhere else. So if we go back to our notes, there's matrix A. We're going to go ahead and put in matrix X. And then all we need to find is A1 times B. So that's our next task, is A1 times B. So next we're going to do this guy right here. So go ahead and choose matrix A and hit your negative first power times second matrix, choose B. And so now we have A1 times B, which is 2, -1, -2. So if we go across, that is X, here's Y, and here's Z. So we have X equals 2, oops, Y equals -1, and Z equals -2. And to write our final solution, we always put that as a coordinate point.